Okay, so we start by the solution of linear equations. To solve a system of linear equation, various numerical methods can be applied. These numerical methods can be divided into two broad areas. First of these involve algorithms that lead directly to the solution of problem after a finite number of steps, while the second involve an initial guess which then be improved by succession of finite number of steps, each step which we call iteration. If the process is applicable and properly formulated, then definite number of iteration will lead to solution. Elimination and decomposition methods are direct methods. For example, Gaussian elimination, Gauss-Jordan Cramer rules, Gauss-Seidel-Jacobi method, and SR methods are iterative methods. Okay. So what he said, to solve a system of linear equation, various numerical methods can be applied. These numerical methods can be divided into two broad areas. First of these involve algorithms that lead directly to the solution of problem after a finite number of steps. So category of algorithms can be divided into two parts. The first is direct algorithms and the second is iterative algorithms. Yeah, iterative methods and direct methods. So in direct methods, we apply this algorithm only once on the problem. And in iterative methods, we apply algorithm repeatedly again and again to solve the problem. Further, in direct methods, there are two kinds of methods. The first one is elimination method and the second one is decomposition method. So Gaussian elimination method is an example of elimination method. Okay, and this Kraut's method, Cholesky method, Doolittle methods are an example of decomposition method because in these methods we actually decompose the matrix of coefficients into two or more matrices. And the example of iterative methods are this Gauss-Seidel method, Jacobi method, and SOR method, successive over relaxation method. So these are iterative methods because we apply the algorithms repeatedly again and again. And for linear equations, what we say that linear equations are linear equations and other basic concepts of algebra have a long history stretching back thousands of years. The ancient Mesopotamians, Egyptians, Greeks, Chinese, and Indians all developed mathematical methods that served as early foundations of modern algebra. So it means modern algebra is based on solution of linear equations, and linear equations are invented as very old because the ancient Mesopotamians use, Egyptian also use, and this Greeks, Chinese, and Indians use this linear equation. But most historians consider the father of algebra to be Abu Abdullah Muhammad ibn Musa al-Khwarizmi, a scholar with the House of Wisdom Academy in what is now Baghdad. So this was called the actually golden age of Islam in Baghdad because this was the time of Abbasid Caliph. So in the time of Abbasid Caliph, the Baghdad was the wisdom of house of wisdom. Okay, and this was the period when these Muslim invented paper for writing, and in that time The European have not paper to write anything. Okay, so that is why we called that the European they stole our knowledge from Muslims, because this was considered as the golden age of Islam when this Abbasid Caliph was in rule, and sometime they made this capital Kufa, Baghdad, and this Cairo. Okay, the definition, how we can define linear equation. A linear equation is an equation in which the terms containing the unknowns are all of first degree. So assuming that the unknown is x, this means that the equation does not contain powers of x such that x square or x cube or x 1 by 2 are functions of x such as sine of x. So a linear equation may have the form. Okay, how we can identify the linear equation? It means if linear equation involve the variable x, then its power must be 1. Okay, it cannot be x square or x cube or x power even 1 by 2, okay, or minus 1 by 2. No, its power must be positive and only 1. And it could not involve these trigonometric functions like sine x, cos x, and tangent x. No. A linear equation may have the form, so it means linear equation can involve more than one coefficients and constants. So it can also be written as ax plus b equal to cx plus d. So no problem. Where a, b, c, and d are constants. Or it can be put into this form by distributing. Any term containing x is called a linear term, and any term not containing x is called a constant term. For example, 5x plus 2 is equal to minus 22 minus x. So linear equations can have one or more variables. A linear equation of two variables is called linear function. Okay, so here we can define what is linear function. A linear equation of two variable is called linear function. Following is the linear equation with three variables. So this is also linear equation. Why? Because we have a power of x is 1, power of y is 1, and power of z is 1. So that is why this equation is linear but involving three variables. Okay, so we are actually interested to write a linear equation in the form of matrices because we want to apply numerical methods to solve a linear equation. Okay, so that's why we need to convert system of linear equation in the form of matrices. In general,
सर
yes,
सर ये जो हमने ऊपर सिंगल वेरिएबल की चीज मतलब टर्म्स पढ़ी हैं लीनियर टर्म की फॉर्म में तो
hmm,
इसको भी तो हम लीनियर इक्वेशंस कह सकते हैं ना सिंगल वेरिएबल की टर्म में
yes, कह सकते हैं.
ओके सर
Hmm.
थैंक यू
In general, the system of m linear equation in n unknowns x1, x2, so on xn can be written as, okay, for example, if we involve n unknowns, so how we can write the system of linear equation? All the coefficients we can put in a single matrix. So we can split into matrix of coefficients and then matrix of variables and then matrix of constants. So if A denotes matrix of coefficients, X denotes matrix of unknowns, and B denotes matrix of constants, then we can write this system as Ax is equal to B. If M is number of equations and N is number of variables, then for M is equal to N, it means if there are three equations and there are three variables, okay, so what we can say, that if the determinant of A is not equal to 0, the system will have a unique solution. If determinant is equal to 0, then solution will not be possible, and we can say the system will have no solution. And for m greater than n, it means if number of equations are greater than number of variables, then what will happen? The system will have no solution. And if number of equation less than number of variables, then the system will have an infinite number of solution. Okay, this we will discuss with examples, inshallah. Equations with exponents greater than 1 are nonlinear. So that is very clear. If the variable involved in equation have power 1 or exponent 1, then we call it linear equation. And if the power of variable or exponent is greater than or less than 1, so then equation will be nonlinear. It forms a curve, and if we increase the value of the degree, the curvature of the graph increase. So we have another identification. Graph of the linear equation will always be straight line, and graph of nonlinear equation will always be like a curve. Okay, so there are two identification of linear equation. Number one, power of variable involved must be 1, and the graph will be like a straight line. And similarly with nonlinear equation, power of the variable involved must not be 1, or it some of the power could be 1 and but not the others 1, and the graph will be like a curve. So if we increase the value of the degree, the curvature of the graph increase. It means the graph will bend more than the previous one. So as soon as we increase the value of the degree, the curvature of the graph will increase. A system of nonlinear equations, in a system of two or more equations in two or more variables containing at least one equation that is not linear. Okay. So for example, if we have a system of three equations and two of them are linear, but one is nonlinear, then also we will say that this is the system of nonlinear equation. Okay, so linear equation impact more than nonlinear equation. Nonlinear equation impacted more on the system. So if we have a system of five equations and there are four equations are linear and one is nonlinear, then we will say that this is actually the system of nonlinear equation. So equation given below is a nonlinear equation. Why? Because the power of this x is not 1 and power of this x is also not 1. Here power is 3 and here the power is 2. But this variable is linear. Okay. But in general we say that this is actually the uh, system of or this one. Okay. We can say that this is non-linear equation. Okay, next is Gaussian elimination method. It's not so difficult. So in linear algebra, Gaussian elimination, also known as row reduction, is an algorithm for solving systems of linear equation. It is usually understood as a sequence of operations performed on the corresponding matrix of coefficients. This method can also be used to find the rank of a matrix, to calculate the determinant of a matrix, and to calculate the inverse of an invertible square matrix. So what is invertible matrix? Whose determinant is not equal to 0. So Gaussian elimination method can also be used to find the rank of a matrix mean how many numbers of non-zero rows in echelon form. Calculate determinant of a matrix, okay, to find the exact value of the determinant and to calculate the inverse. So Gaussian elimination method has a variety of applications. Okay, GR, please send me the attendance. The method is named after Carl Friedrich Gauss, although it was known to Chinese mathematician too. It means at the same time, some of the Chinese mathematicians have invented a method similar to Gauss, but it's famous after the name of Carl Friedrich Gauss. So there are two steps to solve the system of linear equation. Okay. First step is that using elementary transformations, the given system reduced to an equivalent upper triangular matrix. And the second step is that using backward substitution procedure, upper triangular system will yield the required solution. Okay. So what we do in the first step, we actually reduce the matrix of coefficient into equivalent upper triangular matrix, and in the second step we use backward substitution procedure, okay, to find the values of the unknowns. GR, send me attendance, please. Okay.
जी
Gaussian
सर भेज रहे
elimination.
हैं.
Gaussian elimination method reduces the augmented matrix of linear system Ax is equal to B. Okay. So consisting of m equation in n unknowns. What we do in Gaussian elimination method, we make a system of augmented matrix. We can write like this one. Okay. And then to an upper triangular matrix C11, C12, C1, and C22, so on D1. This elimination process is also called the forward elimination method. Here is an example. So solve the linear system by Gauss elimination method. How we can solve this? Just make a augmented matrix, and matrix of coefficient is 1, 5, minus 2, minus 7, and matrix of constant is 7 minus 5. So we can combine these coefficients and constants, and we denote it as augmented matrix. So add twice row 1 to row 2. So what we do, we will just put this or reduce minus 2 into 0. Okay, to reduce this minus 2 into 0, we must have to add plus 2 to make it 0. So it means we will multiply this second row with 2, as first row with 2, and will add in the second row. So that is why we write add twice row 1 to row 2. And what we will get the result 15703. Okay, so in the next step, we can make this 3 into 1, but it is not necessary to make it 1. In Gaussian elimination method, it's up to you. But it's not essential to make it 1. Okay, but if we make it 1, it look like very easy to solve. And when, okay, now see, this is the actually upper triangular matrix because the entries below the diagonals are 0. So that is why we say it upper triangular matrix. So backward substitution method, why we say that backward substitution? Because first we solve this second row and then the first one. So that is why we called it backward substitution. But in this matrix, it's like identity matrix. So we can even apply forward or backward both. So x2 is equal to 3 and x1 is equal to minus 8. So, and the second example is there. Here is the system of equation involve three equation. Okay, 2x2 plus x3 is equal to minus 8, x1 minus 2x2 minus 3x3 equal to 0. Okay, so augmented matrix can be written in the form of this one. So note that here x1 is missing. So there is no coefficient of x1 in the first equation. So that's why we can take 0 as the first coefficient. Okay, and but we cannot operate with the first row. So that is why we switch this first row with the second one to make this first element as a non-zero. So if the first element is 0, we must have to swap the rows, okay? Because otherwise we cannot perform operations. So that's why we swap row 1 and row 2. So row 2, we have we interchange row 2 with the row 1. So now this is the non-zero element. And what we have to do next in the same column, we have to reduce this minus 1 into 0. How we can do? Thus just add this 1 into minus 1, so it will be 0. Okay, it means add row 1 to row 3. So adding row 1 to row 3, here we will get 0, and the same others values will change. Okay, so again it's depend on you. Here you have a choice to swap or not to swap. Okay, so why he has swapped this? Because this is minus 1 and he wants to take 1 on this entry A22. So, but if you don't swap, it will not affect the solution of the system. So it depends on you that whether you swap or not this rows. Okay. So applying this operation, we have get this matrix is an upper triangular matrix. Okay, you are seeing upper triangular matrix. Okay, but these operations are additional. It depends on you. You can perform these operations or you can skip these equation. But here you have obtained this upper triangular matrix and you can perform backward substitution. How? Because minus x3 is equal to minus 2 and this you can substitute in the first one. Okay. So add minus 2 and minus 3. These are additional operation and you will get this x1 is equal to minus 4, x2 is equal to minus 5 and x3 is equal to 2. So that is the Gaussian elimination method. And this Gauss-Jordan method is not so different with Gaussian elimination method. Gauss-Jordan method involve also the two steps. So first step is using elementary transformation. Given system reduces to an equivalent diagonal system. So what's the difference is that in the Gaussian elimination method, using first step, we actually transform the given system of equation into an equivalent upper triangular form. And in the Gauss-Jordan, this given system will reduce into an equivalent diagonal system. And the second step, what's the difference of the second step in Gaussian elimination and Gauss-Jordan is that in Gaussian elimination, we use only backward substitution, but in Gauss-Jordan, we can use backward as well as forward substitution procedure. So that is the difference. And the other one method, this method of Gaussian elimination is in general more efficient than Gauss-Jordan. Okay. Okay, normally we think that this Gauss-Jordan method is efficient, but no. Gaussian elimination method is more efficient than Gauss-Jordan. Why? because Gaussian elimination method involve less steps than Gauss-Jordan. You see here, okay, we will show this difference. Solve the system of equation by Gauss-Jordan. So this is the system of equation. We have made this Ax is equal to B, and then matrix of coefficients and matrix of variables and matrix of constant. We constructed this augmented matrix, okay, and apply the elementary row operation, and we have reduced this system into upper triangular, almost upper triangular matrix, but not surely. But here in these steps, you have this upper triangular matrix, okay. And if you just compare this with the Gaussian elimination method, so here Gaussian elimination method is completed because you have a matrix in the form of upper triangular matrix, okay. But for the Gauss-Jordan method, you have to perform other operation to reduce this system, uh, like this one. So this is the identity matrix. So it means clearly you have performed more steps than Gaussian elimination method. So that is why Gaussian elimination method is more efficient, because Gaussian elimination method has less steps than Gauss-Jordan method. So that is why we say that Gaussian elimination method is more efficient. Okay, the next example is similar as the previous one. Solve the system of equation given below. So here, this is the augmented matrix, okay, and it depends on you whether you swap this first row with the third one or not. But why he has swapped this? Because this entry is 1. But you can also make the first entry 1, but it will give you some complication. Why? Because if you divide this 2 by 2, here you will get 1 by 2, and also you will get 3 by 2. So that is why, to avoid these rational entries, he has swapped this first row with the third row. So that's are the tricks. You can also perform these tricks, and then you will get this upper triangular matrix. You need to perform one or two more steps and you will get the solution. So now we can summarize what we have said in this lecture. So first of all, this linear equation, what is linear equation? So that is have a degree 1, and if we involve more than 1, it will not be linear. So that is a simple identification. And the second one is that graph of a linear equation will always be straight line. Okay. So if we compare with nonlinear equation, the variables involved in nonlinear equation will have degree more than 1 or less than 1 or not equal to 1, you can say. And the second difference is that the graph of nonlinear equation will not be a straight line. Okay, so it will be like a curve. And if we increase the degree of nonlinear equation, the curve will be more bent. Why? Because the curvature will increase of the curve. So simple definition of the linear equation is that the power of the variable involved must be 1, and linear equation could be of many variables in 1, 2, 3, 4, and the system of linear equation can also be written with the help of matrices like this one. Ax is equal to b. Okay, so why we write the system in matrices form? Because we want to perform matrix operations, and we have a rough guess that if the determinant is 0, we will have no solution. Okay, and number 2, if the number of equations greater than number of variables, then also we will not have any solution. So in these two cases we will not have solution, but in all other cases we will have solution. Okay, and then we have studied this Gaussian elimination method and Gauss-Jordan method. So what is the difference between these two methods? These two methods involve the same two steps, but the first step in Gaussian elimination method, we reduce the given system into upper triangular matrix, and in Gauss-Jordan, we reduce the system into diagonal matrix. And in the second step, in Gaussian elimination method, we use backward substitution procedure, and in Gauss-Jordan method, we can use backward and forward both. So that is the main difference. So, and if we go to the invention of linear equation, so linear equations are invented many years back, beginning from the Egyptian, Chinese, Indians. Okay, so this is not so difficult, and this we relate to the name of Abdullah Muhammad ibn Musa al-Kharzmi, a scholar with the House of Wisdom Academy in what is now Baghdad, and this was actually the golden age of Islam. Okay, so